Look at this diagram. On the top, we have what is commonly called vibe coding, giving an AI general instructions and letting it generate code on the fly. It loops, branches wildly, and introduces random bugs. On the bottom, we see spec-driven development. It forces a linear, strictly gated path through distinct checkpoints. We are going to apply that disciplined structure to an existing Next.js app, a simple goal tracker. We have already initialized SpecKit in our repository and locked down our founding rules inside a constitution file, represented by this padlock. That constitution tells the AI our non-negotiables, like insisting on a simple UI and strictly forbidding automated tests. With those ground rules set, our objective is highly specific. We need to add a feature allowing users to rearrange their goals by dragging and dropping them up and down a list. When you inject new code into a mature repository, you cannot afford unstructured generation. If an AI agent operates without rigid architectural boundaries, it will inevitably break existing logic or introduce technical debt. This diagram illustrates the first boundary. We start by completely separating the feature's design from its technical implementation. High-level user ideas go into the top of the funnel, but any technical jargon, like React hooks or local storage, gets filtered out. What survives is a pure Markdown specification document, focusing entirely on what the user experiences. We trigger this by typing the specify command, followed by our drag-and-drop idea. SpecKit immediately isolates the work. It checks out a brand new feature branch and writes our requirements into a clean spec.md file. Because human instructions are rarely perfect, we run a clarify command next. The AI scans the new spec for ambiguities and asks us how to handle edge cases. For instance, it asks us what should happen if a user drags a goal near the bottom edge of a long list. We select the option to auto-scroll, and the AI bakes that decision directly into the spec. This diagram shows the next transition, the plan phase. Here, we feed the Markdown spec into a matrix of our chosen technical tools. We tell the AI to use the sortable library for drag and drop and Tailwind for styling. The output is a highly structured architecture plan, detailing specific data models and strict contracts for our UI components. Before the plan is finalized, the system runs an automated check against our original constitution. You can see the scanner verifying that the plan respects our core rules, successfully confirming our requirement for zero automated testing. By forcing the AI to formalize these technical choices in a standalone document first, we eliminate the risk of the model guessing or hallucinating framework dependencies when it finally starts writing the code. This illustration demonstrates the final abstraction layer. Even a verified architectural plan is too dense for an AI to execute safely in one pass. The monolithic plan must be fractured into a strict sequence of discrete, actionable tasks. We execute the tasks command, and the AI converts the plan into exactly that. It generates a Markdown file outlining chronological phases, from setting up the environment to integrating the final layout. This is the moment to pause and manually audit the generated list. You check to ensure that every single numbered step aligns with the project requirements and that no unapproved steps snuck through. This brings us to a major failure point in AI development: context window bloat. As you see here, when an AI has to hold the constitution, the spec, the plan, the tasks, and all your previous chat history in its active memory, its focus degrades. It gets overloaded and starts making mistakes. To fix this, you open a brand new chat session and select an agentic model. This flushes the unnecessary chat history from the model's memory, leaving only the finalized spec, plan, and task documents for the AI to reference. In this fresh environment, we type the implement command. The AI takes full autonomous control, marching methodically down the task list, generating the code block by block, and checking off each requirement as it goes. Because we separated the planning phase from the generation phase, the AI uses all of its compute power to write precise, functional logic, rather than wasting tokens trying to decipher an endless conversation history. Now we spin up our local development server to test the actual application in the browser. We click and drag a goal, and it smoothly reorders in the list. The UI reacts instantly. The feature functions exactly as designed on the very first attempt, because the model was following heavily vetted blueprints. Look at this flowchart to see the complete cycle we just executed. Step 1, we shape the idea using specify and clarify. Step 2, we define the architecture using plan. Step 3, we build the roadmap with tasks. And Step 4, we execute the code in a new chat. Spec-driven development strips the unpredictability out of the process. It forces the AI into tight, deliberate constraints, turning what used to be a chaotic guessing game into a highly disciplined, highly repeatable engineering workflow.